If you want to take a seat for the next session, and we've got a few people joining us online, I expect too. So if you want to listen in, put your headphones on. Thanks very much. So this session is coordinated by the US Forest Service and Center for International Forestry Research. And it's going to be looking at information on peatland restoration practices, barriers and potential to overcome some of those barriers, and scientific and practical knowledge for greater understanding of peatlands and society interlinkages. And I'm going to introduce our first speaker, who's Noel Gerwick. And Noel is the Senior Climate and Land Advisor for the US Agency for International Development.
Thanks very much. Welcome everyone, and good afternoon, or perhaps good morning, or good evening, or good middle of the night to some of you. My name is Noel Gerwick. I'm a technical advisor in the Natural Climate Solutions Division at USAID, and I have the privilege of managing from the USAID side the Sustainable Wetlands Adaptation and Mitigation Program, which of course has everyone's favorite acronym, SWAMP. For those who are not familiar with SWAMP, it is a partnership between USAID, the Center for International Forestry Research, and the US Forest Service. I primarily want to thank the organizers and the presenters for advancing cooperation on the shared objective of identifying opportunities to restore wetlands, especially at larger scales, and by larger I mean subnational, national, and global scales. I'd like to highlight our appreciation for two particular aspects of that cooperation. And the first is cooperation between low and middle income countries and industrialized countries. A lot of SWAMP's work focuses on responding to the priorities of our partner countries and building their capacity for applied research and action to enable protection, management, and restoration of tropical wetlands. And having perspectives of countries from along the economic development spectrum represented in this session, I think really underscores the shared commitment to addressing this global challenge and the strong need to hear the perspectives from diverse contexts in order to do that. The second aspect of cooperation that I want to highlight is that between SWAMP science team and the much broader community of applied science scientists working on this topic. And I'll add just one more thanks to the SWAMP team and then turn the program over to Eric, who will be moderating. Not too long ago, SWAMP developed a results framework with the organizing goal of that framework being impact. We defined impact as enhanced wetland management in countries where SWAMP works to achieve more effective climate change adaptation and mitigation. And of course, one route to that kind of impact is participation in venues like the COP. So I want to thank again the organizers, the presenters, and all of the attendees and participants for this session. Eric, the floor is yours. Thank you so much.
Hi, everybody. Thank you all for coming today, and to save time, I'm not going to talk a lot. I'm just going to transfer from person to person here. Our first speaker is Florian Humpenöder from the Potsdam Institute for Climate Impact Research in Germany, who's going to speak on the need for restoration as part of natural climate solutions. Florian, the floor is yours.
Thanks, thanks, Eric. Just let me share my slides. All right. Yeah. Thanks for the introduction. So I will talk about the need for restoration as part of natural climate solutions in the context of transformation pathways towards 1.5 or 2 degrees. But yeah, before I go into the details, I would like to give some brief introduction into peatlands and their emissions. So I find this figure quite striking, which shows global CO2 emissions from international aviation compared to emissions from drained peatlands. And as you can see, emissions from drained peatlands is about twice the size of emissions from international aviation. And when I first saw these figures, I was really astonished, because there's a lot of discussion in the media, the public, science, about reducing emissions from aviation, which is of course important, but compared to that, reducing emissions from peatlands seems quite like a niche topic. And of course, I think we are here in the Peatland Pavilion to change that. So where are the degraded peatlands located? That's shown on this map. It shows the drained peatland area as a share of the total peatland area. So for instance, in Germany, where I come from, 95% of all peatlands are degraded. That means only 5% of the total peatland area is still intact. If we look, for instance, at Indonesia, still more than 50% of the total peatland is considered as intact. But if we look at emissions, which is shown on this slide, we see that Indonesia, in terms of emissions from drained peatlands, amounting to more than 680 megaton CO2 equivalents per year, followed by the EU and Russia. And actually, in Indonesia, emissions from peatlands are the single largest source of CO2 emissions, accounting for about 1/3 of total emissions. I'm now coming to transformation pathways, and I think most of you will recognize this figure. It's taken from the IPCC Special Report 1.5 degree, and it shows 4 different pathways of achieving 1.5 degrees by end of century. And it shows the trajectory of emissions over time, broken down into emissions from fossil fuel industry, agriculture, forestry, and other land use, and bioenergy with carbon capture and storage. In all of these 4 pathways, we see that the brown area, which is the emissions from the land use system, turn net negative or even net zero until around 2050 in those pathways. But those pathways do not account for peatlands and their associated emissions. And therefore, the mitigation potential in those pathways from the land system might be overestimated to some extent. And that's why we at the Potsdam Institute for Climate Impact Research included a peatland module into our MAGPIE modeling framework. MAGPIE is an economic land use model accounting for agriculture and forestry at global scale, at the level of different world regions. And MAGPIE was one of the models that had been used in the 1.5 degree report to quantify transformation pathways. So we started off from those pathways using an SSP2 based 2 degree mitigation scenario that have same assumptions for food, feed, material, bioenergy, of course, also including land-based mitigation options such as afforestation and reduced deforestation, and then adding a peatland module, which is driven by a greenhouse gas price. So we use a greenhouse gas price as an economic incentive in this model for peatland protection and restoration. And then we created 3 scenarios. One, default mitigation pathway without dedicated peatland policy, a second scenario that includes peatland protection, and a third scenario that includes land-based mitigation and peatland protection and restoration. What we see in these scenarios is that without a dedicated peatland policy, we would see an increase of degraded peatlands over time. And that's, for instance, because of cropland expansion, maybe also because of additional demand for bioenergy in such transformation pathways. If a greenhouse gas price is put on emissions from degraded peatlands, we see that this could stop further degradation of peatlands. The strongest signal we see if we also reward emission reductions from the rewetting of peatlands. And that's shown here on the right-hand side, and it's a quite strong signal. What does it mean in terms of emissions? That's shown here. And it's partitioning the emissions into emissions from land use change, shown in green color, and emissions from peatlands. And the green color is comparable to the emissions that we have seen in the transformation pathway. So they are turning negative before 2050. But if we add the emissions from peatlands on top, then the agriculture, forest, and other land use sector would not become net negative by end of century. The same holds true also for the case of the peatland protection policy. Only in the case of the restoration policy, we would see that the land system, emissions from the land system would become net zero until 2100. And the point of net zero, that would require about the rewetting of about 60% of present day degraded peatlands. So, okay, but what about methane emissions after restoration? That's a topic that's highly debated, and therefore I would like to bring it up here. And there are higher CH4 emissions after rewetting, but in the long run, there are also lower CO2 emissions because the, the peat is stopped from decaying further. So what counts in the end is the effect on the climate warming. And this has been shown quite clearly in a paper by Günther et al. Last year, that the rewetting of all degraded peatlands, shown here in the blue color, would result in a lower warming compared to no change, shown in the yellow color. So there's a quite clear answer that peatland rewetting, considering also methane effects, would result in a reduced climate warming. Finally, I would like to put peatland restoration into the context of other land-based measures. This figure is taken from a recently published paper from Rowe et al. And this paper compares 20 land-based mitigation options. Peatland restoration is one of those 20. And it comes up with technical and economic mitigation potentials at country level and also at regional level. And if we look at the mitigation density of peatland restoration, we see that this is particularly high. For instance, if we compare it to afforestation, we see that it's about 5 times higher. But at the same time, the total mitigation potential of afforestation is much higher compared to peatland restoration. But of course, that's explained by the fact that peatland restoration is limited to degraded peatlands, which then limits the total potential. Whereas for afforestation, there are much more areas available that can be potentially afforested. So I would like to conclude with 3 takeaway messages. First of all, peatland restoration plays a decisive role for climate change mitigation, even if the methane emissions are accounted for. Second, the land area of our planet can only become a net carbon sink by end of century, which is what the current transformation pathways say, if about 60% of today's degraded peatlands would be rewetted in the coming decades. And finally, peatland restoration is not a silver bullet. So therefore, it should be considered as part of a larger portfolio of natural climate solutions. So for instance, in combination with forest protection and restoration, and of course also in combination with peatland protection. Thanks for your attention. I will hand back to the moderator, Eric.
Thank you very much, Florian, for that great talk. I'm sure you'll have lots of questions at the end in the discussion and question and answer. We're going to move on to our next speaker, Dr. Rupesh Bhomia from CIFOR and Swamp Program, who is going to be talking about effective monitoring and management of peatland restoration. Go ahead, Rupesh.
Hello, everyone. My name is Rupesh Bhomia. I'm a scientist at Center for International Forestry Research based in Bogor, Indonesia. Today, I will be talking about effective monitoring and management of peatland restoration, criteria and indicator approaches. This is a brief outline of my presentation today, where I'll be talking about principal criteria and indicator approaches towards peatland restoration. I don't think I need to go in detail on the definition of peat and what are peatlands. But peatlands essentially store a large amount of carbon, undecomposed vascular plants, and organic matter that provides important nature-based solutions against climate change. Peatlands are distributed globally. A large portion of peatlands are distributed in the northern latitudes, but a significant area of tropical peatlands are also found across the tropics. These are fast disappearing, and action needs to be taken for their conservation and preservation. The role of peatlands in climate change adaptation and mitigation is well emphasized throughout this peatland pavilion. I do not need to go in detail on all the aspects, but one important thing I would like to mention is that the degradation and drainage of peatland is a serious issue, and that's where restoration of peatlands become an important action if we need to maintain peatland as a nature-based solution against climate change. Peatland restoration involves measures designed to help ecosystems to revert to a state similar to or as near to their natural state as possible by re-establishing some of their ecological processes and functions. So essentially, it involves a set of actions that can be monitored over time to allow adaptive, iterative landscape approach that fits well with local conditions, needs, and aspirations of dependent communities. There are various approaches for restoration monitoring of peatland. Some involve collection of data, information on a large number of parameters across the landscape to achieve holistic peatland restoration. Another approach involves use of principles, criteria, and indicators to easily recognize, measure, and monitor key parameters over time, which are locally relevant. In this presentation, I will be talking about the principal, criteria, and indicator approaches towards peatland restoration. Principle is the fundamental truth and will be elaborated in criteria. So principle has an aspirational intent to it. This is how we would like an ecosystem to be. Criteria are the intermediate points to which the information provided by indicators can be integrated and around which an interpretable assessment can be formed. So if you look on the image on the right side, it has an hierarchical level where principle sits on the top, followed by criterion, and then criterion are supported by various indicators. Each indicator will have a specific verifier that is a measure of quantifiable aspect of that indicator. So indicators and verifiers define what information is delivered to evaluate the criteria. Indicators are variable components used to infer the status of a particular criterion, while verifiers contain the data or information that enhances the specificity or the ease of assessment of an indicator. So the principle is mostly one overarching, whereas there could be multiple criteria followed by several indicators and subsequent verifiers. There are four aspects to be considered for successful peatland restoration: biophysical, social, governance, and economic. And for each of these four aspects, we conducted a webinar series in last year, December, where we focused on all these four aspects, and a group of experts participated and deliberated in this workshop to come up with a set of criteria and indicators pertaining to each of these four aspects. In the following slides, I will quickly go over these principal criteria and indicators identified as a result of those webinars. So the principle in the context of biophysical aspect is wet and vegetated peatlands without any risk of drainage and deforestation. Under this principle, we identified 3 criteria and 11 indicators. The principle under social aspect is community well-being and equity is widely demonstrated. This is supported by 3 criteria. which includes social capital, social welfare, and social cohesiveness and harmony. This has 10 indicators. In the context of governance, the principle is just fair and strong governance at all levels. These levels include both government institutions, which follow in an hierarchical manner, but also the non-government, non-state actors, all stakeholders that are involved in the peatland restoration. And the three criteria that fall under this principle are decision-making processes, enabling instruments, and adaptive capacity to change. Under the fourth and an important aspect of peatland restoration is economic. The principle for economic aspect is a viable and sustainable peatland-based economy. As you may all agree that one of the major drivers for peatland degradation is economics. The benefits that people derive often becomes the trigger for those actions. So addressing this is very important when we talk about peatland restoration. The criteria to capture these vast aspects of economy that peatland supports are sustainable and just value chains, economic incentives, wealth, and economic valuation, human resources, and workforces. So all these factors comes into play when we talk about peatland restoration. Following the webinar series where we had deliberations and these criteria and indicators were identified, we had a synthesis and way forward where all these criteria and indicators under 4 themes: biophysical, social, economic, and governance were put together in the form of a working paper which came out a few months ago. Now we are working on identifying the verifier for each of these indicators, and once the verifiers are identified, then these will be field tested and applied in the field. This will all result in a field manual that can be implemented in peatland restoration sites and which can be used for monitoring peatland restoration success and also advise on the actions that can be taken to improve the restoration success. This effort is a joint work between BRGM in Indonesia and CIFOR. We hope by early next year this manual will be ready and it will be field tested in these peatland restoration sites and would provide a useful tool for practitioners and restoration people who are interested in peatland restoration. With that, I thank you for your attention and I'll be happy to answer any questions. Thanks.
Buddy, are you seeing my screen?
Yes.
Are you seeing my talk?
Yes, but not in
I'm
full
seeing it,
screen.
Eric.
Now are you seeing my talk?
Yes.
I'm going to be, my name is Eric Willestad. I'm a research ecologist with the United States Forest Service Northern Research Station and also lead Forest Service swamp scientist in the for the Forest Service in South America. And today I'm going to be talking about peatland restoration as natural climate solution in the Americas. And to constrain myself a little bit, I'm focusing on the United States of America and tropical Andes Amazon countries of Peru, Colombia, and Ecuador. Excuse me. Peatlands cover about 200,000 kilometers square in the United States, about half of which, or 103,000 kilometers square, are in the CONUS, which is the contiguous US and the 48 states, seen on the left as the large image you recognize as the US. That's derived from US Fish and Wildlife National Wetlands Inventory and USDA NRCS Soil Survey of Histosols, which the latter you can see on the left here. Peatlands are not mentioned in current NDCs for the US, but agricultural soils are, so restoration of peatlands now and agriculture could contribute to those NDCs. Our Fargione et al. 2018 evaluated peatland restoration as one of many potential natural climate solutions for the United States. They assessed the difference between historic and current peatland extent by comparing histosol maps, which they consider to be a historic extent, and the national wetland inventory, which is current extent. Using those differences and land use associated with those lands, they estimated that if 100% of peatlands in the US were restored, this could reduce emissions by about 9 plus or minus 2 teragrams of carbon dioxide equivalent per year. And the cost for the majority of these restoration, about 7 of those teragrams, less than $50 per megagram CO2 equivalent per year, not per year total. And then the other two was less than 100 dollars per megagram. Pardon me. To sort of get a handle on what kind of incentives are presently in place in the United States that might sort of support these kind of changes. Right now, we have a program that's been in place for a long time called the Wetland Reserve Easements of the USDA NRCS department. It's not a greenhouse gas focused program. It doesn't, for that reason, it doesn't track peat status. However, easements are held on over 11,000 kilometers square of wetland in the US on former ag lands, and there is potential for some of those to be peatlands and for peatlands to be prioritized in the future if that is deemed appropriate. In addition, there are voluntary markets that are being developed in the US, including the one pictured to the lower right here for the restoration of Pocosin wetlands. Pocosins are a kind of peatland on the coastal plains of the US, and they're in a region with relatively high emissions and low methane emissions in restored peatlands, so they're thought to be a good target. There's an estimate of about 2,000 kilometers square of restorable Pocosins in just North Carolina alone. In addition to restoration, to incentives, we're also developing resources for supporting decision-making on location and prioritization of peatland restoration. If you saw on the histosol map, the state of Minnesota, which is pictured on the lower right of that map image here, is very peat rich, especially that northeast wedge there that's mapped here. We mapped the peatlands in that state based on a process using both soil maps and wetland maps. And then we did an analytical process of using remote imagery and LiDAR to generate a map of the historical ditching impact on the landscape, and found out the 22,000 kilometer square of peatlands map, approximately 1,300 of those kilometer squares were degraded by a network of almost 4,000 kilometers of ditch network. And the estimated emissions benefit of restoration of those lands is about 0.259 teragrams CO2 equivalent per year if 100% were restored. This does not, I want to emphasize, does not include peatlands under ag lands at present, because it's only using peatlands mapped as wetlands presently. So there is probably additional benefit in that landscape for the ag lands as well. Changing gears, this is going to the Sustainable Wetlands Adaptation and Mitigation Program, which, as you heard about, is focused on tropical ecosystems and is supported by USAID. The focus of that program, as you also heard, is developing knowledge and capacity for peatland mapping, carbon cycling, and restoration of rural tropical peatlands, and also for mangroves. In South America, we work intensively in Peru, Colombia, and Ecuador with governments, industry partners, and NGOs. And in that context, starting with, I'm going to go through the 3 countries, starting in Peru, focusing on lowland peatlands of Peru. The government of Peru is developing a peatland definition and also is working on a forest reference emissions level and NDCs for lowland Amazonian peat swamp forests. Preconditions for that are knowing where they are, so map. So and also what the degradation status is. Lowland Amazonian peat swamp forests were mapped by Gumbrick et al. Effort supported by Swamp. But that effort is a global analysis, is uniquely validated in local settings. So there have been recent ongoing efforts to improve these maps using more extensive ground truthing methods focused on just the lowlands of Peru, and several of those are mentioned here. And those are in near just completion or near completion. And then forest degradation, driven largely by native palm tree fruit harvest in the lowlands and these peat swamps, is very different from, say, what you might see in Indonesia, but it's still thought to have a significant impact on carbon storage. The aerial estimates have been made by some members of our group, Garcia et al. From CIFOR, and more comprehensive efforts are in prep. And also the swamp team with one of our speakers, Rupesh Bhumi, also involved working on developing emissions factors for these systems as well. And both of these will be informing the NDC calculations of the Peruvian government. In Peru, mountain peatlands are not addressed by current NDC process because they have not been adequately mapped or assessed for degradation at a national scale. Rough area estimates from mapping efforts seen in the upper left corner of this image show about almost 14,000 kilometers square of peatlands. Again, consider this a little bit better than a back of the envelope calculation. And that's currently being tested and validated by mapping and inventory effort done by the government of Peru. The unit, the International unit in Minam, is doing this analysis with help from us and others. And also, where we have in our docket is to assess degradation by agricultural drainage and grazing, both emissions factors and land use mapping. We have some work on emissions factors published, and we're working on land use mapping methods to intersect with inventory. Sorry, moving on to Colombia. Colombia has been ignored a little compared to Peru, yet the Gumbrick et al. Analysis of 2017 estimated roughly equivalent areas of lowland peatlands in Colombia. This needs validation. Our colleague Juan Carlos Benavides at university partner in Colombia is working with us to produce validated maps of the Colombian Amazonian peat swamp forest extent and condition. And that you can see in the upper left is the Gumbrick map, and the one upper right is sort of a close-up of an area of a map that's being also developed. And the next point here, sorry, I'm moving ahead of myself here, is to focus on mapping of mountain peatlands to support restoration via links to the Powder-Morrison Forest for Payment for Ecosystem program, also funded by USAID, in which we are closely collaborating. And this upper right image shows mapping of both peatlands in the pinkish colors and peatlands on pastures in the orange colors, and shows the ability to detect areas that are intensely impacted. We're also working on emissions factors for degradation and restoration of both the mountains and the lowland peatlands using both chain-based methods and also setting up ecovariance approaches. In Ecuador, we are working intensely with partners focused mainly on mountain peatlands, both national mapping as in Peru and Colombia, also emissions factors, and restoration training. Here you can see a restoration training group on the left here, working on restoring mountain peatlands, trying out some methods. Regional water funds are especially involved in the current restoration efforts. In Brazil, we're not working presently, but there is a need for more intensive attention and effort, given that Gumbrick et al. Identified that country as having the largest peatland extent in South America. And this needs further validation and condition assessment to determine what the next step should be there. And in conclusion, in the US, peatlands could contribute to natural climate solutions. Uncertainties could be reduced by more resolved mapping of peatland condition and more refined emissions factors, in addition to all the standard factors related to incentivization and social acceptance of these processes. In the tropical Andean Amazon countries, progress has been quite rapid in the last 8 or 10 years, and it's been the greatest in Peru, and Colombia and Ecuador are also developing significant resources that are going to be very useful in moving these efforts along. In all, these ongoing developments are laying the groundwork for scaling up of peatland restoration activities in both the US and in the Andean countries. Thank you very much. And I'm going to just zoom past here. Thank you, USAID and all the collaborators, and also citations in case people want to pause and see their screen to see them later. So I'm going to stop sharing now And I am going to introduce our next speaker, it should be Daniel Murdiarso of CIFOR and Swamp, who is going to be speaking on restoration efforts in Indonesia. Daniel, go ahead. Thank you.
Hello, my name is Daniel Murdiarso. I am with CIFOR, Center for International Forestry Research, based in Bogor, Indonesia. Today, I'm going to tell you a story about restoring degraded peatland. That is about how to enhance the ecosystem and community resilience. What have been done, what can be improved in the future, and how science can help. The story begins some 5 years ago, right after COP26 in Paris, when the government of Indonesia decided to restore some 2 million hectares of its degraded peatland across the country. The main challenge and cause of degradation is deforestation of peat swamp forests, followed by draining of the landscape. This has been continued for years, and it has to be stopped and managed properly, especially the drained peatland. So restoration is a complex process, which requires continued monitoring to allow an adaptive and iterative landscape approach. Restoration should be implemented and should fit well with the local condition. So there is no one size fits all, and one should be aware of the needs and aspiration of the local community. Without that, it's going to be very difficult to get people participation, and very likely the restoration process will not be successful. Restoration program should make sure that they engage local community like this, especially local women, to be part of the process. They are part of the planning of restoring the degraded landscape, including what to plant and where to restore. This is an example of establishment of sagu nursery, very unusual and not common nursery to have, but it is very important in this kind of landscape because sagu or metroxylon sagu is very well accepted by the local community, especially in the peatland landscape like this. Sagu is the main source of starch and food for them for generation. So if you look at scenery like this, it is very likely that the sagu just been harvested from perhaps 2 or 3 stems that they are chopped like this and transported into the processing plant. Once they arrive there, usually they remove the bark and extract the starch and then process them to become more lighter, cleaner, and edible starch. Even this kind of product still can be improved to improve the value, I mean the monetary value of this product. One can increase the price 3 to 4 times of the existing raw product like this, and of course it will have to attract the market that are not only local but can be in the neighboring country of Indonesia like Malaysia and Singapore. Another approach to restore peatland is to manage this natural purun grass, very well known in Kalimantan, where people have been using this for years for various local product that is easily marketable, like the mat, and this newly introduced product is called straw. This is certainly degradable straw, which is environmentally friendly. The issue here is how to increase the value of this kind of product, how to improve the market, and also access to financial support for marketing and promoting this kind of product. So degraded peatland can produce this kind of raw material that can be used and assessed by the local community, and certainly it will enhance household business usually run by women in many villages in central Kalimantan. From climate change agenda, restoration, especially rewetting of the landscape and also putting back the vegetation, has a significant impact on the emission as well as the subsidence of the landscape. Depending on the vegetation reintroduced, when the landscape is rewetted, one can expect the emission reduction up to 60%, and the reduction of subsidence up to 30%. This significant impact should be considered as the main tool in order to get the participation of local people, because if the land keep getting subsided, then people will lose their land to be planted. So the entry point to promote rewetting from land subsidence point of view is very important. This is something that science can support. Certainly the emission reduction is something which is significant globally, and with that size of restoration from Indonesia, one can expect a large amount of emission reduction globally. So to conclude, peatland is known as storehouse of terrestrial carbon. So keeping the peat swamp forest intact is very important. But they are so vulnerable due to deforestation and drainage. To enhance their resilience, it is very important to have a comprehensive and integrated approach, not only from the physical point of view, but also from the social point of view, by incorporating, by engaging local community as well as their livelihood. Engaging local community, especially women, will have a significant impact. It is very key to improve their resilience. Women will have their own activity, income generating activity, and this is a significant sign of resilience if one getting there. In a larger scale, innovative business should be encouraged to meet the climate agenda, both adaptation and mitigation, so that business can also be sustainable in that landscape when it is improved and restored. Let me take this opportunity to thank our partners, our donors, USAID, NICFI, and the BMU IKI of Germany. Thank you very much.
Thank you very much, Daniel, for that presentation, and we're glad to see you here for the question and answer at the end as well. The next speaker in our list is Professor Roxanne Anderson of the Environmental Research Institute, University of the Highlands and Islands in the UK, who will be speaking about peatland restoration in Europe. Western, I should say. Go ahead.
Thank you very much, Eric. Can you see my screen okay?
Yes.
Thank you very much. Thank you. The main objective of the presentation today is really to give a kind of an update on a piece of work that was conducted in 2015 as part of the Society of Ecological Restoration. It was coordinated by Professor Lynn Rochefort from the University Laval in Quebec, Canada, and myself. And that was really a stake talk of peatland restoration efforts globally. And that was separated into different regions around the world. And I was responsible for pulling together the information about the peatland restoration status of Western European peatlands. And really the key thing that the important thing to know about Western European peatland is really that they're mostly gone. There has been such a long history of interaction between people and peatland in Europe that most of the peatland area has actually been lost. And the peatlands that remain in Europe is degraded in lots of different ways and greatly diminished in extent. In fact, when we look at this figure here and we see the proportion of degraded area, we can see that most of the countries in Western Europe have very high proportion of degraded peatland. Of course, not all of those countries have high peatland areas, but as I say, most of the areas that remain are degraded or diminished in size. This degradation is a combination of drainage, land use conversion to agriculture, afforestation, and in lots of parts of the Republic of Ireland and the UK, this afforestation was conducted mostly between the 70s and the 80s. But there's also peatland extraction for fuel and for horticultural product. Pollution that has led to loss of vegetation and erosion, for example, in the Peak Districts and the Pennines in England, and overgrazing in areas that are being used for grazing by sheep and cattle. This is really important to understand that the European peatlands are in a really poor condition. They're knackered, as we say here. Green peatlands in the EU are estimated to emit around 220 million tons of carbon dioxide equivalent per year. That is equivalent to 5% of the total EU emission. And I think that, as Florian expressed earlier, these figures are enormous, and really we need to do something about our peatland. And in the review from 2015, what was the key message that came out of that review is that there was a lot of peatland restoration taking place. In fact, there have been between 1993 and 2015 well over 150 projects that had been aiming to restore 91,000 hectares of peatland habitat. The problem with those restoration initiative was that they were mostly in protected areas, so areas that were likely to be in slightly better condition or likely to be not the most degraded, so not the highest emitter. But the bigger problem still was the fact that most of these restoration initiatives did not include systematic monitoring. And therefore, the outcomes of these restoration initiatives was very difficult to understand. It was not clear whether any of those restoration had been truly successful, what exactly the objectives of those restoration, whether they were met, whether the conservation objectives had been met, and importantly, whether there had been any emission reduction achieved through these peatland restoration. And so how have things changed in the last 6 years? And these are really some of the kind of high level messages that I'd like to take are kind of in the next few slides. The first thing that I think, and I've seen change before my eyes, has been the pace and scale of restoration in Europe. Since 2015, there has been an emergence of national peatland strategies and even a European peatland strategy that is being developed and slowly started to be enacted. In most of these peatland strategies, the key objective is to ensure the protection and the restoration, sometimes very ambitious restoration targets over the coming decades. In Scotland, there has been well over 300 projects covering so far 4,000 hectares of restoration, and that's been in the last 7 years through a nationally driven peatland restoration program called Peatland Action. There has been pledges of £250 million to further restore 250,000 hectares of restoration in the coming decades. Similar commitments in terms of proportional restoration area in England as well have been made, and Ireland has also started to come on board with significant investments from Climate Fund and also from Born Mona, with the phasing out of peat extraction and the commitment to repurpose and restore 32,000 hectares of bog. There has been a continuation of those European EU-like funded projects, but an emergence of transnational partnership work. So instead of working only within one country in Europe, some of the countries have started to work together a little bit more to learn from each other and to learn from the development of the techniques that are rolled out across the different countries. One of the examples is the Care Peat project that started last year and will be continuing until 2023 and includes Belgium, France, Ireland, the Netherlands, and the United Kingdom. It has 12 partners that are looking to restore over 600 hectares of peatlands, but do it in a partnership format where the knowledge exchange is increased. Importantly, this has been a shift in the funding from mostly EU grants to more public funding, government, and in particular from climate pots within the public funding. The second things that is starting to change in terms of the peatland restoration in Western Europe is the fact that we are now starting to build a much stronger evidence base. This includes the instrumentation of restoration areas and degraded areas to better capture and constrain the emission and the emission reduction that are possible from rewetting. But it's now estimated that rewetting grassland or drained peat soils could save up to 30 tons of carbon dioxide equivalent per hectare per year. And given the area of drained peatland that exists currently within Europe, these are quite significant numbers. The evidence synthesis, not least the one that Florian presented earlier on, confirms that there are significant emission reduction that we can achieve from restoration and rewetting, where restoration is not necessarily an option. And because we are getting stronger and stronger empirical evidence, we are also beginning to see that restoration trajectories are not always predictable. We might end up with systems that we had not anticipated and systems that are not the systems that used to be, or the peatlands that used to be. In a comparison of 320 rewetted sites, in this case fens, with 240 near natural sites, a recent study from Trailing et al. Highlighted that most of these peatlands were actually different, novel systems with different hydrochemistry, biogeochemistry, and biodiversity attributes, unlikely to function like the peatlands that we currently have and used to have in Western Europe, and likely to need more empirical evidence base to understand exactly how they will function as a climate source, as greenhouse gas sources or sink going into the future. Being able to to manage our expectation with restoration trajectories is really important, because it may be that not all peatlands can be restored to net carbon sinks, but again, the emission reduction, the avoided emission are the key in this particular context. Another thing that is starting to happen and is rolling out very rapidly in terms of development in Western Europe is the development of novel tools, and in particular remote sensing tools that enable us to map peatland condition and also restoration outcomes at scale. Here are two examples of technology that was developed in recent years through a collaboration between the University of Nottingham, a company called Terra Motion, my own university, and NatureScot, the Scottish government agency that looks after, in particular, the Peatland Action Programme. And in this case, we have an example of a classification that can be adjusted year on year to determine whether a particular restoration site is moving towards a desired target outcome. We have now progressed this technology even further and can produce probability map that can determine whether a site is likely to be within a certain category. On the left-hand side, we have a map that highlights on the right-hand side, sorry, we have a map that highlights the potential high carbon loss areas within Scotland and Ireland, Wales, and England and Northern Ireland that could be strategically prioritized for reduction emission through peatland restoration. These maps were derived from remote sensing technology based on interferometric SAR that basically measures surface motion as an integrative measure of peatland dynamic behavior in response to changes in volumes of gas and water. This is a technology that could be rolled out to more peatlands, more different peatland types could be adapted, and could help us understand better where peatland restoration should be prioritized and how peatlands outcomes are developing. Another thing that has happened in the last 5 years is that climate change is starting to have impacts on our degraded peatland. And it is becoming very apparent that the rewetting of peatland is urgent, because rewetting peatland now could increase resilience to severe drought that are likely to become more frequent. For example, here, the 2018 European drought that impacted most of the regions in Europe and caused most of the peatlands that were even in peatlands in good condition to dry out over the summer. Again, here, the empirical evidence is the key. We need to understand how degraded peatlands are coping with climate change, how restoration can improve this resilience, and whether even peatland in good condition are under threat. As well as drought, there is an increasing likelihood that catastrophic and severe wildfires will impact European region and in fact European peatlands as well. And we have seen that evidence on the ground with, for example, the largest wildfire ever recorded in the UK in 2019, where 65,000 hectares of peatlands were impacted. I don't believe that these figures are comparable or significant in comparison with the fires that may impact peatlands in Southeast Asia. However, we have severely degraded peatland that are already emitting lots of carbon. If they burn, more of this carbon will just be emitted more rapidly. Therefore, I think the key messages that are coming out of this talk is that Europe's degraded peatland must be rewetted, but the pace and scale of peatland restoration must increase. And in order to be able to understand how to do that, we need to make sure that it's underpinned by robust science. And what we've seen in the last 5 years is that that evidence is really supporting the peatland restoration and the rolling out of that peatland restoration. Where restoration is not an option, algae might provide an alternative and might enable us to continue with significant emission reduction while maintaining high productivity. And finally, I think European peatlands that are still in good condition must be protected. And I can't think of a better place to start this than with the flow country of Caithness and Sutherland, which is currently a candidate for UNESCO World Heritage Site. And if successful, would be the first, but hopefully not the last peatland to become a UNESCO World Heritage Site because it is a peatland. Thank you very much.
Thanks a lot, Roxanne. That was great. I think you should stay unmuted because we're going to have to go into the Q&A session now. And there accumulated quite a few questions already. We do have some questions we can ask if we run out of questions in here, but let's start with the questions that people in the audience want to hear the answers to. And the first one that was voted to the top is for Daniel. It says at Daniel Murdiarso, and I'll paste it into the chat as well. How robust are the PCI to changes? For example, many of the verifiables are bound to change over time, sometimes non-linearly and unexpectedly with restoration. How is this accounted for? And can everyone unmute in the I think we're supposed to stay unmuted in the chat in the speaker group.
That must be for Rupesh, right?
That's for you, Daniel.
For me.
It says Daniel. Maybe they meant Rupesh.
Okay.
Rupesh,
Yeah.
do you want to do either one of you who wants to do it?
You can start, Rupesh. I can add later.
Eric, can you repeat the question?
The question is in the chat. How robust are the PCI to changes? For example, many of the verifiables are bound to change over time, sometimes non-linearly and unexpectedly with restoration. How is this accounted for? So non-steady state kinds of.
Thank you for that question. So verifiers are in the hierarchical order, are the sort of lowest rung of things, and they are meant to be capturing those changes at a small resolution and short durations. So these are context specific. So while principle remains kind of static for each of those aspects, followed by criteria and then indicators, but verifiers are meant to capture that thing. So these are not set in stone. Verifiers are derived on the basis of local conditions for each of the restoration, for example, at a project level, site specific level, landscape level. So they are meant to capture that. And as things change, for example, in a series where restoration is progressing and a peatland is improving in a condition, then those verifiers will obviously be providing that change. And that's how we capture it. Thank you.
Yeah, just want to add how robust it is. Being a biophysicist, I would say that the biophysical aspect that Rupesh described to me will be much more robust because we can quantify those verifiers. Of course, it will be in a form of range of verifiers, but it will, as Rupesh indicated earlier, be tested in the field. I have least confidence about this social aspect because it will vary from place to place. Imagine if I was talking about degraded peatland with, people introducing sago, people just keeping the wild grass with them. I believe the social aspect would differ significantly from one place to the other. Thanks for the questions. Eric, I don't think we can see the chat. It's only you who can see them.
You all do not see, you don't have, your chat box is not open.
Not that it's not open, Eric, it's that we can't see all the questions.
No, I know that they don't come in the chat. They come in the Q&A. I'm posting the ones, I posted the PCI.
Okay.
I think I hadn't posted it initially.
Only you can see the Q&A.
I posted another one that was upvoted, which was a question to me about our coastal peatlands being considered and monitored in the Americas. And yes, certainly mangroves are a very intensive focus of a number of groups, including our groups, the swamp group, very involved with monitoring these systems and training people on how to monitor them. In fact, we have an upcoming training coming this winter for the Latin American and Colombian region. Latin American and Caribbean region for restoration of mangroves. So if anyone's interested, they could try to contact me and I can put you in touch with the organizers. So they definitely are being considered and monitored, especially, and of course we have coastal peatlands in the southern U.S. in Everglades, which are clearly monitored as well, for example. The next upvoted, looking for ones that are for other folks. They look like mostly for U.S. or Indonesia right now. Rupesh, there's one on here, I'll copy it into the messages. Are the social and economical dimensions considered or expected to be considered among your indicators? And I think you answered that already in your talk. I think it came in at the beginning of your talk. So I think that you already answered that with your talk, with an affirmative on that. And there was a question for me about promoting the incorporation of Andean peatlands into NDCs in Peru. How can we promote that? I don't know if it was clear in my talk that is actually occurring presently in Minam. The Ministry of Environment in Peru is working on incorporating and I'm sorry, Andean peatlands. I missed the question. Andean peatlands requires, I think, a little more information on the mapping and the degradation information fund. So once that information is available, it's much easier to determine how much people can contribute to this problem. There is a question for Daniel, I would like to, these are all great questions, but I would like to give all the other speakers an opportunity to answer questions. So I'm going to post a question here that we developed ahead of time, which I think for the speakers to address is, what are the biggest barriers to achieving large-scale effective peatland restoration as part of natural climate solutions in your region? How do they differ among countries and regions? And I'm going to rotate through. Florian, do you want to go first on that?
Yeah, thanks, Eric. Well, there are a couple of barriers, I would say. So one barrier is, of course, monitoring. So MRV, monitoring, reporting, verification. So because what works very well in a model, like we did in our study, tracking emissions, pricing emissions, is actually a very difficult task in reality. Roxanne showed that there have been advancements in the last years, but still I think that monitoring the outcomes of a restoration project is one of the biggest challenges. And then, if you allow me to continue, a second barrier is probably also one point Roxanne brought in, namely this bit like white thinking between it's used for productive, for agriculture, or it's completely reverted back to nature. And I think there is something in between. That's paludiculture. That means it's wet agriculture. Still, it's reverted. So that means the water table is raised, the decay of peat is stopped, but still it can be used in a productive way. And for instance, it can be used to grow reed or peat moss, which can be used as building material. It can be used for paper, for biogas, for creating energy. So, and I think that's also important to, or could be also a vehicle to convince landowners to change the practice how they use their land, because in the end much of the land is owned privately, and people are using this land to generate income, and if they are not, I mean, they need to be rewarded for that in a way to rewet the peatland. And paludiculture could be one example of how peatlands could still be used in a productive way.
Thank you. I'm getting some questions for Roxanne now, so I'm going to wait on asking you our general question, Roxanne. And there's one here I'm going to post in the chat, which says that Roxanne, you said that in recent years, one of the changes you had observed was the scale and speed of restoration in Europe. Do you think that public perception of peatlands also changed as rapidly? And including the wider panel, are there any lessons to be shared about engaging the public?
That's a really good question. I think the answer is probably no, but it has changed, but probably not as rapidly. I think if I take the example of Scotland, because this is where I'm based and where most of my research is conducted, there has been a massive effort in terms of the scaling up of restoration that has delivered restoration at scale. We're talking thousands of hectares at the time, often whole catchments being restored as a single initiative, but we're not quite there in terms of the landscape scale delivery. And one of the reasons for that is that there is still a little bit of hesitancy in terms of taking up restoration, and there is still this perhaps misunderstanding of the role that peatland could have if they were in better condition in terms of greenhouse gas emission mitigation, but also co-benefits from biodiversity and water. I think there is a changing perception, but I think we still need to continue to bang our drums, and we still need to continue to use evidence to support this. I think that the more evidence we can put, the more robust this evidence can be, then the more likely, and there's my daughter crying in the background, the more likely we are to, she doesn't like peatlands being degraded, that's what she's saying. So the more likely we are able, and I think a lot of it will have to start with education and with younger people being aware and understanding the importance of peatland and being able to carry that forward.
Thank you, Roxanne. While I've got you on stage here, there's another question that was asked about your talk, which is what is the impact of drought on more intact peatlands? Is there a risk of a negative trajectories in response to increased drought frequency?
So some of the research that we've conducted here on droughts, including using the surface motion data, actually suggests that there is a very strong resilience mechanism in intact peatland, whereby the surface of the peatland can collapse because of the irreversible collapse of the internal pores, for example, in the mosses or within the peat. And that in turn leads to a post-drought condition that is wetter than before the drought. However, this mechanism needs to be built up over time. So you need to have the accumulation of peat before you can have that surface shrinkage. And the risk is that if there are too many repeated droughts, then even peatland in very good condition will not be able to cope with these repeated impacts of drought. What we have seen here in some of our peatlands that are in good condition was that there is areas that were then impacted subsequently by drought, by wildfires. So there's this potential also for feedback loops to start between droughts and fires that could be more that could lead into these positive feedback loops in the future. And I think that building up resilience by rewetting peatlands now is probably a safe path to take, and that the longer we wait, the more likely these degraded peatlands are not going to have enough time to build that resilience to future drought cycles that are likely to become more frequent.
Florian, I have another question for you that's been voted to the top here, so I'm going to post it right now. With the emphasis on methane at the moment, how do we convey to policymakers the importance of CO2 emissions reductions, going for the low, slow, but long-lasting impact rather than the quick win?
Yeah, thanks for the question. Sorry, just trying to understand. I have to read the question again to understand it. So just give me a second. Well, I mean, in terms of peatland, that goes together. I mean, in the end, one can choose between ongoing CO2 emissions from degraded peatlands and low CH4 emissions, or if you rewet a peatland, you get lower CO2 emissions, but yes, you get higher CH4 emissions. But I think there is increasing evidence, as also shown in the talk by Roxanne, that the net effect of that on the warming in the case of peatland rewetting is actually a reduced climate warming. So that's quite clear, and from that perspective, it's not a choice between higher warming from CH4, but of course it has to be seen together.
I think it goes to Daniel. It's about cultivation of species that grow in undrained peatlands. It depends much on the demand of the market. How do we make products made from sago, purin, etc., have a worldwide demand?
Okay, thank you very much. So sago is one of those paludiculture species, and it is very difficult to introduce or reintroduce when the land is drained and when the people are not ready to do that. So reintroducing sago should be to those who get used to it for a long time. And that's why pulling the water back is very important to be able to meet the requirement as paludiculture practices. And the demand about the market of the product, I think it's very much related to how the local community get together to have enough power to influence the market. We watched the situation in Riau province, very close to Malaysia. The price of this product, which is still very coarse, if you wish, very not too clean. I think the price is somewhere around 10 cents or something like that in US dollar. But if you sell it like that, and then the buyer will process it a bit, you can multiply the price. So accessing market should be accompanied by improving the product. So value chains is very important, but understanding the supply chain is also important. So combining the two will be very crucial to help the local community sustain with that kind of practice. Purun is very specific, and usually the market is also very specific. So you have to make sure that the supply chains is well understood, so that if you try to expand the market, it's very likely that you have to involve the local community in various exhibition or things like that, so they get exposed to this kind of, potential buyers. And usually, if they are exposed to this, the price will be much higher than it used to be.
Thank you, Daniel. Ash, there's a question for you. What are or expected to be the most challenging aspects to assess the social and economic dimensions of the restoration project indicators? And maybe Daniel could join in on that as well once that presents.
Rupesh, you want to start?
Yes. Yeah, so as such, social and social dimensions are more difficult than economic, because there is a quantification aspect to economics. You can see the benefits that are being derived, what kind of income being generated, how many people are being involved in those activities that are based on products coming from peatlands or the agriculture in the drained peatlands. The social dimensions, as I mentioned, about the indicators of social well-being, cohesiveness, and the community well-being is very important. And the challenging aspect is, how do we quantify it, and how do we relate between two sites, two peatland restoration sites, and the community makeup, who are dependent, who are living in that landscape, could be very different with their own cultural beliefs, their practices, and so on and so forth. So these are some of the challenges, and through our team, through field testing, that's where we are trying to capture this, trying to assess this, what is most important aspect, and when peatland is restored, how that is being viewed in the context of their so in that community, social relationships between institutions. And that's where governance also comes into play, which is not mentioned in the question, but this is the interplay of governance and social. So I don't know if I'm able to answer it, but this is something that we are testing it in the verification process and trying to address it. But those are challenging for sure. But Daniel, you want to add something?
Yes, we just talked with our team when we developed the indicators and also the potential verifier for social aspect. And the list is getting longer and longer, but it's going to be very hard to quantify those items that we identified as verifiers, because the potential facilitator in the field told us that if you are asking this kind of questions in a successful restoration, the answer might be different with those which has failed. So how do you do that with that kind of situation? So we end up with very long list of wide range of questions. So we might end up with scoring them in order to be able to compare the indicators and verifiers from one place to the others.
We've got a question about one. I'm going to ask the general question again to Roxanne. What are the biggest barriers to achieving large-scale effective peatland restoration as part of natural climate solutions in your region? And then there's another question for you as well, Roxanne.
I think the same barriers that Florian highlighted are very much the same. So the kind of the monitoring, verification, and reporting is really one of the elements that will add credibility, and also that will open the path to potential financing and kind of enabling or unlocking those private finance that may want to invest in peatland restoration, because there is a benefit to be made in terms of carbon credits, you know, derived from the peatland reduction emission, the reduction in emission achieved from peatland restoration, unless you have a very strong, empirically funded, robust and trustworthy monitoring, verification and reporting system that enables you to do that at scale, at the same scale that you want your restoration to be achieved. That isn't going to work. So there has been development in the UK, for example, with the development of the Peatland Code that enables some of the accounting of carbon emission reduction based on underground verification. But if you want to roll out peatland restoration at the landscape scale, it's not necessarily compatible with that ground-based measurement. You need to turn to remote sensing solution but to have those remote sensing solutions, they need to be validated and they need to be recognized and they need to be acknowledged as well. So I think that's one element. And then obviously I think the other element is unavoidable is the funding. It costs money. You know, capital investment into peatland restoration. It costs a lot of money to do peatland restoration. And the more peatlands are degraded, the more it costs money. And of course, there is support from public finances, but it's not going to be enough if we want to restore all of the European peatlands. We need far more than what is currently committed in terms of public finances. We need to bring in private investment. We need to be creative in the way that we can bring in funding, not only to offset those capital investments in terms of the first restoration interventions, but also to enable the continued intervention that may be required in the longer term to maintain some of those you know, restoration outcomes. So it may be that you need to go and block the drains in the first instance, but you may need to go and revisit a few years later to reblock some of the drains that might have failed. And if so, there are a lot of, it's not just a one-off intervention. There is a long-term process that needs to be taken into account. And in the same way that the funding needs to be, you know, in that kind of long scale as well. So peatland restoration is not a quick fix. It's going to take time to get those peatland back into good condition. And the funding should also be long-term. And so should the empirical evidence that support it. It should also be long-term and should be supported in that kind of same long-term perspective. I think these are some of the kind of the barriers that are there, but are also kind of societal barriers, if you like, in terms of the uptake of peatland restoration or the understanding of the role of peatland restoration, where, for example, there may be, you know, perceived conflict in policy between afforestation and peatland restoration is a good example. So they can go together very well, but they could also be perceived as being conflicting, and resolving some of those perceived or real conflicts is another barrier that we need to overcome.
So I think before we shut down, I'd like to ask Daniel the same question, because I'd like to hear the perspective on Indonesia for this question. And again, the question is, what are the biggest barriers to achieving large-scale effective peatland restoration as part of natural climate solutions in your region? You are muted, Daniel.
From the tropical peat swamp forest perspective, especially in Indonesia, I think the examples from the local leaders, both formal and informal, would be very crucial, because if you don't have any example like that, it's going to be very difficult for small scale operators or local community to be part of that restoration program or project. But the main issue they have really is because the land ownership or tenurial system is not very clear and strong. It's quite different with what I just heard, for example, in Ireland or in Scotland. So in Kalimantan or in Rio, Jambi provinces, they are not the owner of these lands. So it's going to be very difficult, to have this kind of sense of ownership if you introduce a program and then try to keep that going for a long period, unless the ownership or tenurial is secure. So that will be the main challenge.
That's really an important contrast for these systems. Really important. I think we're almost out of time, and I wanted to give Rupesh a minute to close us out here so we don't go over time. So with that, I'm going to pass over to Rupesh, who's going to make a closing statement here.
Thank you, Eric. So first of all, I'd like to thank Eric for shepherding us and keeping us on time, doing a good job as moderator. And then I would like to thank all of our panel members, speakers who joined, and Daniel, who is awake at past midnight, as well as others who joined in a little bit good time. But it was a very productive session, and I thank you all. Before I close this session, I would like to thank Noel Gerwick to also introduce SWAMP program, and for all the support that USAID has given that has allowed us to conduct this research and share some of that as a part of this session. So with that, I would also like to thank all the attendees and participants who have been engaged here and raised some very interesting questions that allowed us the discussion. So with that, I thank everyone and wish you a very good time at COP26. Thank you very much.